Here's part 2 of Lab 7. We're going to be starting on page 178. This is a diagram that shows station models, and these are stations that are put on weather maps that show all kinds of information that you can see at a glance about the weather at a particular location. Here's part of a weather map that's in this lab, and for example, at Atlanta, Georgia, they have this station model here, and all of these numbers represent certain things. And meteorologists know what that information is because each item is placed in a certain location. So we're going to learn how to make these. We're not going to put as much information around our station models as is listed here, just a few things such as shown here. Now you'll see on this weather map that several of these cities have information around them, but then there are other cities like Charlotte, Roanoke, Nashville, Birmingham, that don't have any information around them. And so those are actually for you to fill in. So we're going to do that together right now for one of these cities, and then you're going to do the rest. All of the information is given on this page, and this page is something that you're going to want to have available for quizzes and your next exam. So the information that you're going to put on your weather map is here on page 180. And I know I'm skipping page 179 right now. We'll come back to that later. So the information that you're going to put at each station is shown here. Cloud cover, wind direction and speed, temperature, dew point temperature, pressure and pressure change, and precipitation. All of the cities that are in bold are the ones that you need to do. The rest have been done for you. So I'm going to do Birmingham, Alabama with you right now. We're going to start with percentage of cloud cover. That information is shown here. And what you do is you shade in the circle that is placed on the map where the station is located, and you shade in that circle depending on the amount of cloud cover. And students always ask me what this one on the bottom means, sky obscured. I think that just means that for some reason they were unable to take a reading of the cloud cover, and that's just what that means, no reading available. So in Birmingham, Alabama, there was an 80% cloud cover, and so 7 to 8/10 cloud cover uses this symbol right here. So let's go to our map. I've blown it way up so you can see the detail, and that's the symbol, or as best as I could do, for Birmingham, Alabama. And I am going to do all my symbols in red just so you can see them clearly. And by the way, we're doing number 1 here on activity 5. After cloud cover, we're going to look at wind direction and wind speed. For Alabama, the wind direction is from the southwest. Remember, it's from, not to the southwest. And the speed is 15 miles per hour. Wind speed is given in this chart. Wind direction we'll put on when I show you the map. But wind speed is going to be represented by one of these symbols. Now 15 miles an hour falls right around here. And so the symbol we're going to use is a long feather and a short feather. I call these feathers. So here's our station. And we're going to indicate southwest winds by this straight line to the southwest, and then our long feather and our short feather. And now you can see the other stations indicating their wind directions. But remember, this means the wind is coming from the south, coming from the southwest, coming from the southwest, coming from the northwest. Next, let's put temperature and dew point temperature on there. Remember that the dew point temperature is the temperature to which it would have to drop for the relative humidity to become 100%. Temperature is always listed in the upper left, and you always drop the degree sign and the Fahrenheit or centigrade symbol. Dew point is always listed in the lower left, and again you drop the units. So in Birmingham, Alabama, the temperature is 70 degrees and the dew point temperature is 64. So in we put 70 and 64. Next, we're going to put air pressure and pressure change. And here we're not going to put all of the details that they use in their model. Barometric pressure is put in the upper right. There's a convention that's sometimes used where they drop the 9 or the 10 in the front of the air pressure symbol just to make it a shorter number. We're not going to worry about that. We're going to just put the entire air pressure number. So ignore this strange number right here. We're going to put 1004 for the air pressure of Birmingham, Alabama in the upper right. And then the change in air pressure in the last 3 hours, we're just going to put the number and a minus or plus sign depending on whether the pressure dropped or rose. So if it rose, it's going to be a plus sign. If it dropped, it's going to be a negative sign, and that's given here in the column. We're not going to use these symbols over here. We are, however, going to use this convention, which is to drop the decimal point. So minus 1.4 will be minus 14. So let's put those on our station model. We have 1004 for our air pressure and minus 14 for the drop. Now you can look around and see that these other station models are starting to make sense. The temperatures are in the upper left, the dew point temperatures are in the lower left, air pressure change, and air pressure. The last column is precipitation, and there isn't any in Birmingham, Alabama, so we don't have to do that. But in places where there is, you put precipitation in the lower right. And these are various symbols for precipitation. So if we look again, now I've kind of backed the map out, you can see a couple places that do have precipitation. In Chattanooga we have drizzle, in Louisville and Evansville we have snow, down here in Jackson, Mississippi we have a thunderstorm. So the first thing you want to do is complete the other 8 station models. Birmingham is the 9th, and then you can go on to the rest of the lab. Now let's go back to that page I skipped, 179. You should now be an expert at doing this. This was kind of a warm-up with the station model. The first one, question 1, asks you to describe the percentage of sky cover, wind direction, wind speed, temperature, dew point temperature, pressure, and barometric pressure tendency. That has to do with this thing right here. I suppose you could figure that out. And then you're going to annotate a station model in the way that I just showed you. So this was going to give you practice for the map. So now you can do that and move on to the map. All of that was number 1 for activity 5. You've got all this information on this map. And this is why I told you to start early with this lab, because it does take some time. Now that you have all the data on the map, you're going to draw isobars. And they've already drawn the 992 isobar right here. Remember, that connects all regions that have that air pressure. They ask you to begin with the 996 millibar isobar. These are going to be every 4 millibars. So this map is incomplete, obviously, because I'm not going to give you all the answers, but we do need to know a little bit about the air pressure of these nearby stations, so I've put them on here. The first isobar we're going to do is the 996 millibar, and so you can see that there's 996 millibars of air pressure in Indianapolis, Nashville, and there's already been one done for us, that's 996 in Columbus. So we know our isobar is going to pass through those 3 cities. So I've drawn a line through them. Now Chattanooga is 1,000, so it's going to be outside of our isobar. Roanoke is 1,000, that will be outside of our isobar. Chicago's 1,004, that will be outside. Even Evansville is 997, and that is more than 996. So now we can connect our dots, so to speak, and really we have some freedom here because it's not clear where exactly to draw these lines, but this is one possibility. And then you want to label it 996. Then we want to go to the 1,000 millibar line. I happen to know that none of these out here are 1,000. They're all greater than 1,000. But we do have 1,000 here in Chattanooga and Roanoke. Nothing else is 1,000. But Evansville is less than 1,000, so we need to go outside of Evansville and include it inside the isobar. And again, we have some freedom on the shape we want to make it. So that's the idea. I'm not going to do the rest for you. Remember, you need to do this after you have the air pressures listed on all of these different stations. Oh yes, and put your 1,000 in there. Number 2 says, use the weather plotted on the map to determine the location of a cold front and a warm front, and then draw them. So one thing I recommend is go back and look at this mid-latitude cyclone, because that's what you're ultimately drawing here. One thing that you can notice is this cold front separates regions where winds are coming from the northwest, and see, winds are coming from the northwest here, and winds from the southwest, which we can see here. Now, we don't know what's going on at Memphis and Shreveport, so we don't know whether we want our cold front to be here or here, and that's going to be for you to decide. But that wind direction is going to be very helpful. Also temperatures, right? Temperatures out here, 46 degrees, 46, 41. Out here, they're 72. So temperatures are going to be warmer ahead of the cold front and colder behind it. So you're going to figure out where that cold front is going to be. But I'm telling you, it's going to be approximately in here. Then the warm front. Similarly, warm front has air coming from the southeast ahead of it and the southwest behind it. So here we have southwest air, and it's a little variation, but up here we definitely have southeast air. So your warm front's going to be somewhere over here. Step 3 on the next page says label air masses, MT, MP, or MC, that are likely located to the northwest of the cold front, to the southeast of the cold front, and to the northeast of the warm front. So those are really in the same places as these. And then indicate areas of precipitation by lightly shading with a pencil. You can see areas of precipitation because of these symbols that you put on your map. The next thing you're going to do for question 3 is you're going to assume that this mid-latitude cyclone that you now have complete is moving to the northeast in the way that I showed you in the earlier video where the entire system moves from west to east. Provide a forecast for each of these cities to figure out how the weather's going to change. So right now in Chattanooga, that's the first one they're asking about, we've got winds from the southwest, there's some drizzle, the temperature is in the 60s, I can't quite read what it is. What's going to happen? Well, we know the cold front is over here, right? We know that the cold front hasn't hit it yet. So basically, you're going to describe the weather that's going to happen as the cold front hits this. Chattanooga, you can think of as being somewhere located in this part or this part of the diagram, right? It's going to experience the weather that C is experiencing as the cold front approaches and moves by. So that's the idea there. Then you're going to do this for Little Rock, Jackson, Mississippi, and Roanoke. So talk about how the clouds will change, the rain, the temperature, the pressure. Finally, we have the lab report. This is really a review of everything you've done. This is a very busy lab. You really learn a lot. We're putting together everything we've learned about meteorology. And then the culminating figure here is another weather map, another mid-latitude cyclone. And they're asking you to describe the current weather in Minnesota, which is this MN here, Pennsylvania, which is PA, and southern Georgia, and here's Georgia. So good luck. See me in my office hours if you need help. There's a lot going on in this lab, but it really will make you feel good when you get it all done. Good luck.